Hello and welcome to The Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm Elijah, and today we're looking at the fascinating story of when nature inspired a high speed revolution, which is the Japanese Shinkansen, or more widely known as the bullet train, and a tiny diving bird. In this episode, we will explore a classic and powerful example of biomimicry. I'll explain the fascinating problem faced by Japan's world renowned bullet trains, or known to the Japanese as a Shinkansen train, which the problem was a sonic boom that plagued residents living near the tunnels. We'll then dive into the solution engineers discovered by observing the kingfisher bird. We'll break down the process of how they took a bird's beak shape and applied it to the 200-mile-per-hour train. This is a journey of discovery, evaluation, and exploitation of a brilliant design in nature. Finally, we'll look at the legacy of this innovation from even faster Shinkansen bullet trains and into the future of aviation with aircraft noses. To truly appreciate this story, we will have to go back to the 1990s. Japan Shinkansen, or known to us here in America as the bullet train, was already an engineering marvel and taking passengers across the country at incredible up to 200-mile-per-hour speeds. However, it had a noisy secret, as when these trains approached tunnels, they would create a massive pressure wave which would build up inside the tunnel and leave a thunderous boom at the tunnel's exit. This would shake windows and disturb residents for up to a quarter mile. This threatened the expansion of the high-speed rail network due to Japan's strict noise regulations. The engineering team at JR West, or the West Japan Railway Company, were stuck. Their traditional engineering solutions weren't working. However, one of the lead engineers on this project was Eiji Nakatsu, and he was a bird watcher. He wondered if a bird could hold the key to this solution. He then thought about the kingfisher bird when he was bird watching one day. This bird is an exceptional hunter, and it dove from the air into the water at a high speed with almost no splash. A big splash would alert its prey. His team studied the beak's shape and found long, sharp, and progressively widening was the secret to the bullet train's nose. This was the light bulb moment. The problem with the train entering the tunnel was the same as the kingfisher entering the water. They made the discovery and formed a hypothesis which is just the beginning. However, now came the rigorous phase of evaluation. Engineers at JR West first started with computer modeling and CADing for this nose for the new bullet train design and creating digital simulations of the various nose cones shaped, inspired by the kingfisher's beak. They ran many tests, tweaking the angles, the length, and the curvature of the bullet train nose cone. The next step was physical testing, since digital testing can only tell you so much. They created two-scale models of the new train nose and tested them in a wind tunnel. The new results they found were fascinating, as it led to a more quiet and aerodynamic design in the open air. The problem led to the resolution of the sonic boom problem, but the train would also use less energy. JR West moved to the exploitation phase, where they debuted the new design of the 500 series Shinkansen, which debuted in 1997. The sonic boom was effectively eliminated, and the passengers enjoyed a smoother and quieter ride. The environmental impact was that it reduced up to 15% electricity, and the operational costs for the railway lowered due to the trains going faster. Newer Shinkansen models like the Alpha X continue to redefine aerodynamic principles to push boundaries of speed and efficiency further. This has even leaped from the rails to the skies, as aerospace engineers are using the Kingfisher beak design to make more efficient aircraft nose designs to reduce fuel consumption and noise during flight, as they did with trains in the 1990s. Today we covered how a critical noise problem with the Japanese bullet train was solved by mimicking the kingfisher beak. We follow the journey from an engineer's simple bird watching observation to the creation of a train that was quicker, quieter, and more efficient. Thanks for listening.